Hey everybody, and welcome to our lesson on solving equations that have special solutions. So when you solve an equation, one of three things can happen. You can have a single solution, just one number that makes x true. You can have a no solution equation, and you can have infinitely many solutions. Okay, so let's take a look at each of these and see what happens. All right, one solution is what we've already been studying. Only one value of x will make the equation true. So when you work it out, you're going to get something that looks like x equals a number. Okay? Let's look at this example. So if you remember when we studied multi-step equations, there was two things you had to check for before you just started solving. One was parentheses, the second was like terms. So in this equation, we do have parentheses. So we're going to multiply using the distributive property first. 3 times x is 3x, and 3 times 2 is positive 6. That's the only thing we multiply. I'm just going to rewrite the right side of the equation. Now in this equation, I don't have any like terms on the left side of the equation, and I don't have any like terms on the right side of the equation. Remember, for them to be like terms and we can just straight up combine them with adding or subtracting, they have to be on the same side. So we look at the left side, and then separately we look at the right side. So no like terms on this one. Now if you remember, I use what I call the box method. So you box a term, and that means that term cannot move. Now, since I have two terms on the left and two terms on the right, I get to choose which one I box. Most of my students like to just box the first term. So let's say we box the 3x. The rule is if you box an x, you have to move an x. So I'm going to move that 2x using inverse operations. So that's a positive 2x. That minus goes with the 9. And to make a zero pair with positive 2, I need to subtract 2. So I'll write it there because that makes a 0. And then I'll write it in my box. And then I calculate my box. 3x minus 2x is 1x, which is just x. Then bring everything else down in order. So plus 6, then my equals. Now be careful here, there's a minus in front of that 9, so I bring it down as negative 9. This step, we're going to box again, but we have to box the term that's by itself. So on the left side of the equation, I have x and I have 6. On the right side of the equation, I only have negative 9. So I have to box the negative 9, and it cannot move. That means I'm going to move my 6. It's a positive 6, so the opposite of that would be to subtract 6. Again, positive 6 and negative 6 make a 0 pair. So I have x equals, and I calculate that box, negative 9 minus 6 is negative 15. Now, what I would suggest that you do is I would pause this video, and I want you to try the 4x minus 9 minus 7x equals negative 4x plus 13. Pause the video, give that one a try, and then push play, and let's work it out together and see if you got it right. All right, let's see what you did. So I don't have any parentheses on this one, so I skip down to step 2, which is like terms. If I'm looking at the left side of this equation, I have 3 things, and 2 of them have x's. So I can put the 14x and the minus 7x together. Now, I did circle the minus in front of the 7 when I circled my like terms because that tells me how to combine it. So in my thought bubble, I'm thinking 14 subtract 7, which is 7. So those two combine and make 7x. Bring down the minus 9 equals, and then just bring all this down. I don't have any like terms on the right side, so it just stayed like it is. Okay, now we can box and solve. Again, we can just box this first one. You can box a different one if you want to. If I box an x, I have to move an x. So if I box 7x, I'm moving the negative 4x. To make a zero pair with a negative 4, I need to add 4x. Okay, negative 4 and plus 4 make 0. And then I go left to right. So my box comes first on the left. 7x plus 4x gives me 11x. Then bring down the minus 9 equals, and then the only thing not crossed out on the other side is that 13. From here, I have to box the one that's by itself, which is that 13. Okay, I box a plain number, so I move a plain number. So I'm going to move that minus 9, and to make a zero pair, I'll need to add 9. Okay, so that cancels out. So I have 11x equals 22. And then remember my little rhyme, when they're side by side, you need to divide. So 11 and x are side by side. So we're going to divide using our fraction bar, that means divide. We'll divide by 11. Now notice we are not changing signs there. You have to divide by the exact coefficient of x. 11 divided by 11 gives me 1x, which is just x equals. And then calculate this box, 22 divided by 11 equals 2. So hopefully you got x equals 2 when you gave it a try. All right, so that's kind of a review of the other multi-step equations that you probably already know how to solve. Let's talk about the special solutions. Let's talk about no solution first. No solution means that no value of x is going to make that equation true. What's going to happen is you're going to start working this equations, and all the variables are going to cancel out. So all your x's are going to go away. And you're going to be left with two different numbers. So some number, and it's not going to equal the number on the other side. Okay, what does that mean? Let's see what that looks like. Now, we've got a big long equation here. We remember our steps. Parentheses first, then combine like terms. All right, so negative 2 times 3x is negative 6x. And then negative 2 times positive 1 is negative 2. And instead of writing plus negative 2, I just go ahead and write minus 2 like that. Now, I don't multiply the 4x by negative 2. I just write it down. And then nothing needs to happen on this side of the equation, so I just copy it down as well. All right, if you look at this, we've got 3 terms on the left and 2 on the right. So on the left side, something's got to combine. We've got negative 6x minus 4x. Well, negative 6 minus 4 is negative 10. So when I put those together, I now have negative 10x minus 2 equals negative 10x plus 5. What do you notice there? We've got negative 10x on the right, and we've got negative 10x on the left. Let's keep working in case we didn't notice that. Let's say I box this negative 10x. That means I'm moving the other negative 10x. So to make a zero pair, I would add 10x. And what happens is I have a zero pair here, and I have a zero pair here. See how all those x's went away? Well, what's left over on the left? Negative 2. What's left over on the right? Positive 5. Those two numbers are not equal. So this equation has no solution. Okay, once again, I recommend that you pause this video and you work this example, and then come back and let's see if you got it right. All right, let's work it out. I bet you guessed that it is a no solution, but let's prove it by showing our work. All right, we've got two sets of parentheses here, so let's just start on the left side. Negative 4 times x, negative 4x. Negative 4 times positive 5 is negative 20, so I write minus 20. And then just bring down the negative 3 or the minus 3, however you want to say it. Okay, on the other side, we also have parentheses. So we're going to do 2 times negative 2x. which is negative 4x, and then 2 times 6, or you can think 2 times negative 6, which is negative 12. Okay, combine like terms. Our like terms this time do not have an x, they're just constants, but that's okay. Let's go ahead and bring down our negative 4x, and then let's put our constants together. Negative 20 subtract 3 is negative 23. And there's no like terms on the right, so I'm just going to copy it down. All right, time to box. And if you notice, again, we have the same variables on both sides. Okay, so if I box the negative 4x on the left and I move the negative 4x on the right, I'm going to add 4x, which makes this a 0 pair and this a 0 pair. Okay, so let's write down what's left over. On the left, I have negative 23, and on the right, I have negative 12. Those two things are not equal. That's a false statement because negative 23 did not equal negative 12, so this has no solution. Oops. Okay, the last special solution is infinitely many solutions. And this means that all values of x, or any value of x, will make the equation true. And what I mean by true is that the number that's on the left side is going to equal the number on the right side. Again, all your variables are going to cancel out. But this time, you're going to be left with equal numbers. So some number on the left is going to equal some number on the right. All right, let's work out this example to show you what I'm talking about. All right, we do have parentheses this time, and we have like terms. So we have like terms on the left, and we have parentheses on the right. So let's go ahead. We'll try to do 2 steps in one. On the left side, I'm going to put 4x and plus 2x together. 4 plus 2 gives me 6x, and then bring down that minus 3. Okay. On the right side, I need to do distributive property. So 3 times 2x is 6x. 3 times negative 1 is negative 3. Stop and see what you notice. The left side matches the right side exactly. Now, sometimes you don't notice this. You're just working through it, and you're in your math brain, and you just keep working. So let's say I just kept working, and I boxed this 6x, and I moved the other one, so I know I need to subtract 6x. Well, this made a 0, and this made a 0. Well, what's left over? On the left side, I have negative 3, and on the right side, I have negative 3. Those two numbers are equal. That's a true statement. So this equation is said to have infinitely many solutions. All right, pause the video and give this equation a try. There's a lot going on in that equation. And then come back and let's see if you got it right. All right, let's check your work. So let's do distributive property first. We've got negative 6 times 2x, negative 12x, negative 6 times positive 1, which is negative 6. Then just write down the negative 5. Okay, that takes care of the left side. On the right side, we've got 3 times negative 4x, negative 12x, and then 3 times negative 3 is negative 9, and then just bring down that negative 2. Okay, next step, combine like terms. So let's look at just the left side first. I've got these two constants that I can put together. I'm going to go ahead and bring down the negative 12x. Negative 6 minus 5 is negative 11, so minus 11. Okay, let's do the right side. I'm going to go ahead and bring down the negative 12x. And I have these two constants. Negative 9 minus 2, also negative 11. And if you can see, we've got the exact same thing on the left side and the right side. Okay, if I go one step further to prove that it's infinitely many solutions, I box my negative 12x, which means I'm going to be adding 12x here. So that makes a 0, and that makes a 0 pair. On the left, I have negative 11, and on the right, I have negative 11, which means I have infinitely many solutions. And that's our lesson on special solutions. Thanks for joining us.